Let's look at section 4.3 to determine whether events are disjoint, and then I jump to calculating the probabilities using a table. I did not do anything with the complement, but all the complement is, if I asked you to find the complement of 92%, or in probability 0.92, all you do is subtract 100% minus that value, or in decimal 1 minus that value, and it'd be 0.08. So that's all the complement is. Alright, decide whether the following two events are disjoint: electing a president of the US and electing a female candidate. These are not disjoint because the events can actually occur at the same time, meaning you could have when you elect a president, it could be a female candidate. How about randomly selecting someone who plays basketball or randomly selecting someone taking a statistics course? Now, you might not think somebody that plays basketball they're too cool for statistics, right? But both of these could occur at the same time. You could have somebody that's playing basketball and they're taking a statistics course. Alright, now you're going to have a lot of table probabilities, and it's important that you understand how to read the table. So this following data summarizes results from 1,000, so if you added all these up, you'd get 1,000 pre-employment drug screening tests. If one of the test subjects is randomly selected, find the probability that the test subject had a positive test or a negative test. In probability, and this is very important, the word or means to add. In probability, the word or means to add. Where the definition to add probabilities is to find the probability of a positive test or a negative test, is you find the probability of a positive plus the probability of a negative, and you subtract out the overlap, the intersection between the two. This overlap right here is if they are disjoint. So are they? Yes, they are, because the test cannot be both positive and negative. Joint, this piece right here just becomes 0. So we don't have to worry about it, but we like to always write it out in the formula so we don't forget about this piece right here. Alright, the probability of a positive test, well, the positive test results are in this column. 77 and 99 probabilities is base divided by the total number of outcomes, which in this case was 1,000, so I get 0.176. The probability of a negative test, I add the negative ones divided by the total number, I get 0.82. And now I add these two together, and remember this was minus 0 out to the side, and hopefully this would make sense to you that this better be equal to 1, because that's the only thing that can happen. You can either have a positive test or a negative test. All probabilities must add up to 1.